very much, Katerina. Thanks, everyone, for coming, and good afternoon. My little story, very short, is, yes, Jacques Cousteau had a lot to do with me becoming a marine biologist, but I wasn't in the Mediterranean. I was in 5-degree water. I learned to scuba dive in Ireland with a wetsuit when I was in university. 5 degrees in the winter, 10 degrees in the summer, but hot whiskies were actually quite good to get over the hyperthermia that you experienced every single dive. Anyway, so today I'd talk about the research that we've done on the juveniles, and this is just the team of people that's been working for us, and lots of people to think, like the COTS control and all the supply train. And I'd like to acknowledge the traditional owners of the Great Barrier Reef and its catchments as the First Nations people holding the dreams and traditions of this beautiful area. But also the Gadigal people of the Eora Nation is where I do my work, because I haven't been working on country, because we get our COTS shipped to Sydney. So we do all our work on COTS in Sydney. All right. So COTS life cycle, I won't say very much because most of you know about it. It spawns, has a larva. Now, what we worked on was this stage here, the transition between the very, very early juvenile to, and this pink later stage juveniles, which is the herbivorous. They're pink because they eat coralline algae, and they get the pigment of their food. And then, of course, then you've got the coral eating stage, is where we have stopped our work. So these animals are. Our work sort of started off with the hidden army hypothesis. I had a student about 12 years ago doing ocean acidification and COTS, and she had some leftover juveniles, and so we didn't know what to do with them, so we just threw them. Looked at them after 2 years, they're still there. Looked at them after 3 years, they're still there. I says, oh, right, I know what's happening. So let's have a look at this possible hidden army hypothesis. So then another student came along, Dion Deker, and then she did this work. And yes, indeed, they're there. They are very hard to detect. And so obviously they're very, very hard to study. Jennifer Wilms, a shout out to her, because she did a heroic job of finding these darn things on the reef. Pretty amazing. So the aims of this work was to look at the influence of waterborne cues, the behaviour of these juveniles, to their various cues that they would get in the environment. Crustose, coralline, algae, that was the CCA covered with rubble. My suitcase was full of rubble that I brought home from Montreal Island, so it was the real thing, and some adult conspecifics that you got courtesy of the COTS control divers, and various combinations. Our hypotheses were that the juveniles would be able to identify their food source, the CCA, as also a nursery habitat as well. But when it came to the adult conspecifics, we weren't sure. Would it be a signpost to go there because that's where the coral is? Or, as we found out with Marthasteres glacialis in Ireland, was that maybe they would not be attracted to the adults. So let's just say sort of indication of a density-dependent mechanism happening. So this was the setup. I won't go into any great detail. It was just the header tanks. This is the flow chambers, and a shout out to Mike Kingsford, because he had put juvenile fish into the same thing that we put juvenile COTS in. It was a really good array that we finally decided that works for these juveniles, and we presented the cues in flow through, the Y maze, and then we characterized whether they went up or down, which direction they went. And we did our experiments under red light. Initially, we did them using police body cams in the complete dark. Thank God we didn't have to keep doing that. And then eventually we got the array working really well, and then we used time-lapse photography and tracked them. And the data analysis there, just for your completeness. So just don't worry about this figure on your left at the moment. You're going to see it again. So we had 4 cues types. We had just plain old filtered seawater, 1 micron UV filtered seawater, try to avoid any bugs that might be in Sydney Harbour. And we've got the coral and CCA and adult COTS, and a various combination of these cues and how would they respond. just filtered seawater only. This is sort of expected. They moved, some moved upstream, some didn't move at all, and the downstream movement was significantly different, but most of the COTS either moved upstream or into no movement, and sea stars tend to move upstream, so that wasn't too much of a surprise. These are the choice responses, and again, you're going to see these again, but we have, if you look at this, is that you've got CCA-rubble, blue is just water, the oh God, my sight is horrible. So we've got, the pink is the CCA, the blue is filtered seawater, the direction is that either downstream or upstream. And you'll be seeing more of these choices now, and I'll go over the data with you. So the choices with single cues. So this was the run with just single cues, and so you have here CCA, the COTS, and the coral. The color seems to have changed in this. Anyway, so they went for the yellow, and is the habitat, either the CCA or the coral, and the red is the avoidance. So this was our first indication that the juvenile COTS actually avoided the cues from the adults. And then you've got with the two choice, which then made things a bit more complicated, and that's the two choices in this one, is that you've got coral attraction. They preferred coral to CCA. This was at the stage when they were able to eat coral. But then when we got to the combination of COTS and coral, the no movement was strongest, and when we had COTS and CCA, we had no significant result. Essentially, when we saw the juveniles in the presence of an adult, regardless of where the nursery CCA-covered rubble was there, or where the coral was there, the juveniles meandered, they weren't sure what to do. It was definitely not a black and white response as we saw with a single cue. So to try and tease this out, then we took our movies, so we filmed them, and we tracked the behavioral responses. So we had, so just tracking the responses. This is these squiggle lines. We literally tracked every single individual. And so first of all, we got to the single cues. So when the rubble was by itself, CCA-covered rubble, this was the most direct path. The juveniles mostly went straight to the CCA-rubble arm of the Y maze. It was the shortest distance moved and the fastest movement. So they could definitely, and remember, these juveniles have never seen any of these cues in their life. So this is a first, they're naive. The tracking response to corals, that was interesting. Again, they were attracted to corals, and it was a direct path, the short distance, but it took the longest time for them to make a choice. They were slow. And it kind of indicated some sort of cautious attraction, and maybe that's warranted because, as people have seen and various people have published, the transition to being a coral predator is a bit hazardous for COTS because they can get stung and killed by the coral tentacles. But they're attracted nonetheless, but a bit more cautiously. And I'll just say, I should really explain what all these axes are. That's speed of movement, time to make a choice, and distance moved, and we got all that information from the movies. The tracking response to COTS, well, they really meandered. Most of them went downstream, and the rest of them kind of went up into the filtered seawater arm. And this was the greatest distance moved. They were really quite indecisive. It took them the longest time to make a choice, and their choice was away from the COT, away from the adult source of the adult cue. So what we find out from this work is that the herbivorous juvenile COTS have strong sensory abilities. They can navigate a distance, navigate towards cues coming from a distance that they have never seen before. So this is an innate response of these juveniles. They move directly towards cues from CCA-covered rubble. and that indicates a strong attraction to the nursery habitat. They find, in other words, they find home quickly. They had a positive response to coral, but it was a bit more tentative, and maybe that hesitancy with respect to the dangers of the juveniles in their transition to the coral eating stage. When it comes to the adults, they moved away from the cues of the adults, and the adult avoidance may indicate what we might see in here, and we've seen in other species of sea stars: density-dependent recruitment, a population feedback mechanism, and that's whereby they avoid competition from the adults. If the adults are there, they don't emerge. And this really does support that juveniles in waiting hypothesis, and that the juveniles can accumulate in the reef infrastructure over multiple years and transition to corallivory, transition to become coral predators as the opportunity arises, maybe after a COTS outbreak has gone and there's still food around. There's more work on that to tease that one out. And really what the management implications of this are that the COTS control programs, when they remove the adults, do they release the juveniles from competition, so that causing the juveniles then to switch to a coral diet, that hidden army emerging? And because we know that some reefs on the Great Barrier Reef, even Moran said that 20 or 30 years ago, that it takes a long, when you remove the adult COTS, all of a sudden there's more COTS there again. Just when you think you've got them all, you come back, there's more again. So that could be that more again may be the juveniles emerging once they've been released from competition from the adults, that hidden periodic emergence of the hidden army. And COTS, as Charles Birkeland said, has a lot of Faustian traits, and this is one of the Faustian traits of COTS. It's really an inconvenient truth, really, that they have huge plasticity. That's one of the reasons why they're so successful. They have stress resilience. They're really tough. Both the juveniles are quite tough, and they might be in the reef infrastructure, and once the availability of, when the coral prey is low, and then such as following a bleaching event or a cyclone or a COTS outbreak has gone. So when there's low coral cover, the juveniles are still there, but in the reef infrastructure as herbivores. So the implications for coral reefs faced with climate change is in this scenario is pretty dire, really, is that if in a warming world, because we do know the juvenile waiting stage COTS are far more resilient to heat waves than the corals. 12-degree heating weeks did not knock them back at all. The coral was all dead, but the COTS were all quite tough. They don't mind heating. To a certain extent. They didn't like 36 degrees, but neither does the coral. So the warming world residing in the rubble may benefit from an increase in the extent of this horrible. So this is an insidious feedback. You've got bleaching, as we're seeing now on the Great Barrier Reef, and I tell you, Montreal was just smashed in heron. The rubble from the bleaching, that rubble collapses. It gets covered in algae and CCA, and that's the food of the COTS. So now you get an insidious feedback whereby coral bleaching kills COTS, creates more rubble. Rubble gets covered with coral and algae, and that's happy days if you're a juvenile COT. That's not happy days if you want to keep a reef happy. This is the scenario from that paper, waiting stage juveniles. If you see them here in the little coral, this is this little cartoon that my student Matt made. They're there in the rubble, and this is a normal reef. Then the reef bleaches, and then it gets covered with algae, but the juveniles are still there. The reef collapses, way more coral, rubble, a lot more food. And eventually you'll get something like an acropora recovering very quickly and growing, but the juveniles there are in waiting. So it's an interesting scenario, but I think it's a scenario that we really need to take on board and considering in our management models. And that's it. And I'd like to thank everyone that's involved in that. This is Monique, who did all the work in the dark. She's a very tall woman, and the crew. And I'd like to thank the Great Barrier Reef Foundation and the CCIP guys, COTS control guys that got the COTS first in the first place. Thanks very much for listening, everyone. Oh, bye, Steve.
The issue with releasing the juveniles, do you know how big or how adult an adult needs to be before the juveniles are wanting to avoid them? So does a 15 centimetre adult still have the same effect on the juveniles and making them avoid? I'm just thinking because when we control, we usually, the 15 centimetre adults we're not really getting. So I was just wondering if that's enough to keep would that be enough to keep the pressure on them?
That's a very good question, but I would suggest that the chemistry of a corallivorous cod, whether it's this size or this size, is probably quite similar. The only difference between a very small cod that eats coral and a big cod that eats coral is probably the gonad chemistry, the reproductive chemistry. So I suspect not. I suspect they're just detecting competitors out there.
Yeah, so I'm just, in that case, it could be, if we are releasing the pressure, if we're focusing on the larger individuals, we still might get the competition by leaving the smaller adults there.
Yeah. You have to take everything off.
Yeah.
Yeah, thanks, Maria. And that was a good talk. I just wanted to comment, or maybe hear your comment. If the juvenile in waiting is true, it's obviously, because to be honest, not all of us have supported culling all the time, because we were worried that it would lead to what we call the Okinawa situation, right? That it's a continuous outbreak, we're culling and new COTS are coming up faster and faster. So if your juvenile in waiting was true, that would be one mechanism to create this and would probably could be taken as an argument against culling COTS.
Yes.
Thanks.
Yes. I think you've really got to understand what the feedback is between the juveniles, and there may be a critical number. Like, for instance, Marthasteres glacialis in Lochine in west of Ireland. Those big Marthasteres, and they're really big sea stars, their density did not change in 20 years, but the juveniles were always there in the waiting. So all we could figure is as one of the adults popped off, another juvenile would pop in, but it was stable for 20 years in 3 different habitats. The recruitment habitat, the intermediate habitat, and the adult habitat. Something happened similarly with Pyzaster or Cratius in west coast of North America, and Mary Sue found that one.
Well, sea cucumbers do that by asexual reproduction.
Yeah.
What this is for her, but they keep very stable populations just by replacing all mortality with asexual.
So really sorry, we could go on forever with talking about echinoderms, but the interesting thing is it does run through echinoderms, and I think normally, yes, echinoderms will not be so silly to eat themselves out of house and home, but something's gone wrong with the barrier reef, and it could have been overfishing.
So we will work through questions from Scott, and then the plenary will start in 6 minutes over.
Sorry.
Okay, I'll try to quick. Maria, another question about this release hypothesis. I just wonder what happens when you take into account space, in the sense that, you know, if you've got areas of rubble versus areas of live coral, is it going to apply so much in the sense that, you know, the rubble is great habitat for the juveniles, but maybe there doesn't tend to be a lot of adults around because they'd prefer to be on the live coral?
Yeah, no, that's a good, those juveniles that are in the rubble that don't have adults around, yeah, they're probably not getting that communication. But once they grow up, they're going to have an imperative to grow. So they will biologically want to move to a coral-eating space, adults or not, because they want to grow up and want to have children. So the thing is, that's what Zan showed in Fiji. It took 2 years for the juveniles to move from the reef flat to the reef crest. When they went over 50 to 100 meters, those juveniles moved.
Okay, thanks, Maria. I think we could talk about COTS for the next 50 years.